Hello, can you hear me?
Hello, Mr. Rahman. Yeah, good, good.
So, how are you?
I'm good. I'm good, Mr. Rahman. So nice to see you back.
Yeah, so after a long time, we meet again for our new online training program
Yeah,
on Google Earth Engine. So, I hope you are also
yes.
enjoying this all of those classes. So, basically, it's a total 15 days online training program. And in this online training
Okay,
program, we are trying to cover all of those
okay,
method in Google Earth Engine platform, different types of remote sensing analysis. Okay, all of those things will be covered. So first of
okay,
all,
okay,
I will try to discuss about that our course module or course
okay,
content.
okay,
Okay, so after completing the
okay,
total 7 days, what you will learn. Okay, all of those things we try to discuss. Then
okay.
move to our class.
Yeah, Mr. Rahman, you said 15 days means 15 classes?
Yeah, 15 classes. Yeah.
Okay, okay,
Okay. And all of those classes, I will give you some assignment or this type of work. So you also try to do for that because you can get the time because only one
uh,
days in a week. So other time you can get the free for
yeah,
your assignment or the practice.
okay, okay.
Okay. So
Sure,
let's
sure.
go.
Yeah, yeah.
Just I simply first of all try to discuss about our course model. Okay. So let's
Okay, okay.
okay. So yeah.
Mr. Rahman, I just want one small request from my
Yeah.
side.
Please.
Yeah, I will be sharing one shape file of this region, Mr.
Yeah.
Rahman.
Okay. So you
Okay,
can also send me the
on
shape file. Then I also do
yeah,
all of those analysis using the same shape file. Okay. Then you can also get
I
the
know.
better understand about all of those things. Okay. No problem about that.
Yes,
Okay.
yes, yes, yes.
So you can send me the shape
Okay, yeah,
file.
yeah.
Okay. So after completing the
Sure.
today's class, send me the shape file from the next class. I just use your
Yeah.
own shape file and do the different types of analysis. Okay. Okay,
Okay,
so
okay,
let's
okay,
go.
okay, Mr.
Okay, so basically, it's a
Yeah.
total 15 days of complete online training on Google Earth Engine for advanced remote sensing
Okay,
analysis. So basically, in this online training
okay,
program, you already completed my basic online training program for the 7 days. Okay, which will be
ah,
21 hours. Okay, we already complete this part. So now I hope we can easily learn all of those things about this new advanced online training program. So basically, in this online training program, first of all, I talk about the course content. So in this online training
hmm.
program, I talk about the RUSLE model. Okay, so mainly it's
Okay,
we are used for the RUSLE model for that estimate the soil loss estimation. Okay, and where
okay, okay,
and also find out the higher we can find out the more soil loss or less soil loss. So we are talking about the RUSLE
okay,
model and show you that how much
okay,
soil will be losses for the different time period or annual, how much soil will be losses. So this type of analysis I try
okay,
to complete it. And we also talk about the
okay,
NDVI change detection. Okay, such as for the different
okay,
time period, what is the
okay,
condition of the NDVI and
okay,
how to detect the
okay,
change in vegetation over the time using
okay,
NDVI.
okay,
In this time, we also
okay,
try to
okay,
discuss about the monthly, annual, or seasonal rainfall analysis. So, what is the condition about the
okay,
monthly, or annually, or seasonal rainfall for the different types of rainfall pattern and also trend
okay,
at the different temporal
okay,
scale. And we also try
okay,
to discuss about the something about the land use land cover classification using machine learning. So in this time,
okay,
I
okay,
talk about that all of those machine learning approach, such as how
okay,
random forest will be worked, how
okay,
classification and regression will be worked, how minimum
okay,
distance will be worked. So all of those things will be covered in this time. And then we talk about
okay,
the LST, land surface temperature, and NDVI time series chart for various land use and land cover classes. Suppose what is
okay.
the condition for
Uh,
the
you,
LST for the vegetation? What is the condition about the
okay,
LST for the urban land?
acha, acha.
Okay, as well as we just try to make the interpret the relationship between the land use and temperature and vegetation health. Okay, so we also try to discuss
Okay,
about
okay.
that, and we also try to discuss
The,
about the yeah
Mr. Raman, one
yeah please
request, like
yeah
when you're discussing on the rainfall data
yeah
information,
yeah.
can we also deal with the the prediction of rainfall? Can we do that?
Okay, prediction is not. done in this time, because for the prediction we need to use here the paid version of Google Earth Engine platform. Okay, Google Earth Engine paid version, then we are use the prediction option on different types of prediction model we can use in the paid version for the Google Earth Engine. Okay, so without prediction we
Before
just
that,
use the different types of past year and then try to find out the trend. What is the trend about that for the suppose 2023 or 2020? What is the trend?
I understood, Mr. Ahmed.
Yeah.
But
So
with any machine learning techniques, can't we predict? Can't we predict it for the next few years
yeah,
with the present last 20 years of data?
yeah. Yeah, then you
Can
can
we?
also predict, but this Google Earth Engine for the prediction is not possible to use the free to use. Then we have to buy the for their license for their use the prediction model. Okay, but it also do for the another way for the another Python programming language. Suppose we have the some suppose non raster data. If suppose we have some numerical data, so using
Yeah,
this
this is no
numerical,
numeric data.
yeah, then you can easily do it. There is no problem. Okay, and we can also predict for the future what is the condition about the rainfall. So I already
Yeah,
make
yeah.
a video about that. So I also send you about that. Then you can easily get the suppose you have the some numerical data. So now you want to
Yeah,
identify or
Excel data.
yeah, it also possible. Yeah,
Uh,
it also possible. Yeah, yeah, it also possible. No problem about that.
okay.
Okay.
Yeah.
Okay. And then we also try to discuss about the satellite-based heredity index to monitor the drought condition and access the drought using the satellite.
Drought condition.
Yeah, drought.
Okay. Heredity index.
Yeah, using the heredity index.
Okay. Okay.
As well as we also discuss about the land surface temperature monitoring using the Landsat imagery, and also utilize the Landsat data to monitor the land surface temperature change. How we can easily use for the Landsat 5, Landsat 7, Landsat 8, or Landsat 9 for the LST.
Okay.
We also talk about the linear regression model, okay, and trend analysis.
This is
Okay, so
this
what is the
for what?
trend? Yeah.
Linear regression is for LST.
Any data set. We can use any data set. It
Okay.
can be LST, it can be NDVI. So I show you the one
Okay.
approach. Using the same approach, you can do for the any data set, in LST or NDVI, anything. Okay.
Okay.
Same
Understood.
approach.
And this LST change, analysis, we can be working on the old data sets also, Mr. Eman. Like for example, how much in during 1990s, how is it? 2000, how is it?
Yeah.
2010, how is it?
Yes. Yes. We can easily do it. Yeah.
Okay.
Yeah.
Yeah. Okay.
Yeah. As well as
Fine.
after linear regression, we talk about the man candle test. How we can easily use the man candle test and also make the long-term trend of NDVI. Okay, using the same approach, you can also do for the LST and use the man candle test. Same approach. There is no problem. Okay.
And one more thing.
Yeah, please.
This man candle test, Rahman, Mr. Rahman, the long-term analysis you're saying, right?
Yeah. Yeah. Same.
With this, can we go for prediction?
Okay, so in this time, it's not for the prediction, but it's showing about only for that. Suppose any region, drought. Okay, so in this time, it find out the drought region over a specific time period. It easily find it using the man candle about that.
Oh, this man candle. The main usage of this man candle is to derive at the heredity index.
Yeah. It was possible. Yeah. Yes.
Heredity.
Yeah. And also do for the NDVI or NDWI, anything we can easily apply the man candle test and detect the trend. Okay.
This is mainly used for getting the trend analysis.
Trend analysis. Yeah. What is the high trend or where is the low trend? Okay. This type of analysis we can easily get from here.
For
As
the
well
last,
as,
say,
yeah. And we also talk about the monitoring the VCI, TCI, or VSI. Mainly, it's all of those the three index. We are mainly used for the three index for identify the drought condition and analyze the vegetation health or thermal condition overall vegetation condition indices. How it will easily create the VCI, TCI or VSI, and so make the time series chart about that. Okay. Then detecting the deforestation, how we can easily detecting the deforestation using the machine learning method. Okay. And how to identify
Okay.
the deforestation
Detection
using
of
machine
deforestation.
any forest, any.
Uh-huh.
We can easily
Okay. Okay. Vegetation. You mean to say vegetation?
yeah. Then we
Loss
talk
of vegetation.
yeah. And then detecting the deforestation. Okay, classifying the soil. Okay, suppose we just classify the soil and calculated the area. Okay, suppose
Soil,
1 degree
soil or soil? Soil.
it's soil. Okay, so
What
dam,
is
from
that?
the dam, how we can easily calculate the slope. Suppose 1 degree angle, how much
Okay,
area is
slope,
available?
slope.
Yeah, slope. Yeah,
You mean to say slope?
yeah, yeah. And classify
Okay,
the
okay.
slope and the calculate area using the Google Earth Engine platform. And after that, classification of NDVI and calculated the area. So mainly we are using at the different types of threshold. Using this threshold, what is the condition of different types of NDVI classes, and also calculated the data and area. Then extraction of raster. Suppose any raster, it can be NDVI, it can be NWI, anything, any raster data. How we can easily extract the point sample in Excel file with a specific coordinate. Okay. Then we talk about the some monitoring the bioclimatic variable, how we can easily use the different types of bioclimatic variables, analyze the bioclimatic variable to understand their impact on ecosystem. We also discuss about that. And then how to monitor the monthly evapotranspiration. We also talk about the evapotranspiration and how we can easily get the monthly evapotranspiration and monitor the water cycle through the evapotranspiration cycle. We also discuss about that. And then monitor the
Okay.
soil
Water
salinity.
cycle.
Yeah. What?
Evapotranspiration and water cycle.
Yeah.
Water balance cycle. Huh?
Yeah. 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 And then we talk about the monitoring of soil salinity index. Okay. And assess the soil salinity using the remote sensing. How we can easily access the soil salinity using the remote sensing technique. We also discuss about that.
Okay.
As well as also discuss about the landslide, how you can easily make the landslide susceptibility using the Google Earth Engine and also help of ArcGIS software and make the landslide susceptibility mapping. We also talk about the flood mapping. Yeah.
Actually, Mr. Rahman, in this region, I think there is no much landslide
Okay,
vulnerable areas.
then I can
Yeah.
change it for my own area. Suppose hill district area, I can choose and then show you the example. It is a better, yeah. And then we also discuss about the flood mapping using the Sentinel-1 SAR data and calculated the flooded area using the SAR data. Okay. And then we also try to discuss about the trend analysis of NDVI and how we can easily use the NDVI for the trend for any region. Okay. So in this time, there are the total 20 topics. Okay. And all of those topics has a lot of things. So that's why in this time we take some time for completing all of those things. And step by step we try to complete all of those things such as RUSLE model, NDVI change. All of those topics will be covered. There is no problem.
Inshallah.
And we try to complete. There is no problem. Okay. So let's go for the first test. So mainly today I will discuss about that RUSLE model. How we can easily work with the RUSLE model in Google Earth Engine platform. So mainly spatial estimation of soil erosion using the RUSLE model. Okay. And this is the algorithm about the RUSLE model. Mainly there are the total, you can see soil data. We need the soil data, rainfall data, dam data,
RUSLE, right? RUSLE.
Yeah. So in this time, this type of
What are the data required? What are the data required?
satellite data. Okay. For the soil
Satellite
data.
you're saying soil data.
Yeah. We can easily get the soil data from the satellite, soil picture. Rainfall data, we can get the satellite. Suppose charts data, dam data, we can use the NASA SRTM data. Land use data, we can get the Landsat Sentinel Modis. Okay, anything we can easily get. Okay. So in this time, I talk about this algorithm and then how we can easily implement the RUSLE model in Google Earth Engine platform and create this type of map. You can see it's showing the Bangladesh soil erosion map. and where is the
Mr. Evan,
slide.
I'm not getting any image. I mean I'm getting your profile only.
Okay, you can, yeah, so you can easily get it. You can also get my YouTube channel. You can get my LinkedIn profile in here. There's no problem. And also you can follow my research get profile also. You can get easily. Yeah. So in this time, here you can see it is the Bangladesh soil erosion map. And in this time, we can just use this model and then try to
One second, Mr. Rahman. I'm unable to see your screen.
Okay, just a minute. Why? Okay, just a minute. Okay. Okay, so now it's visible, yeah. Yeah, now visible, yeah. Now
Yes,
can
yes,
you see?
yes.
Okay, okay. Okay, so let's go. Okay, so now I can see it, yeah. Yeah. So now here you can see here, this is the RUSLE model. This is our algorithm about that. And from that, using this type of data, we need to just suppose soil data, rainfall data, dam data, land use data, mainly this 4 data type we need when you want to do for the RUSLE model.
Okay, okay.
And using this
Okay.
model, we can easily create this type of map using the Google Earth Engine platform. And after that, we can easily show the result in ArcMap software. Okay, we classified the severe dry, severe, then also very high, moderate, and slight. Okay, so in this time I discuss about the algorithm, then show you the practical example using the Google Earth Engine platform. Okay, so let's go. Now, basic introduction about that RUSLE model. Basically, RUSLE model is the empirical model, and it's mainly to predict the long-term average annual soil loss on a field. Okay, so mainly in the RUSLE model, we can get the annual soil loss. And then it's developed by this W.S. Wismer and the D.D. Smith. Okay, they developed this model and began, it will be started from the 98th century and estimate soil erosion based on total 5 factors. Okay, and you can see here the RUSLE model. So basically, RUSLE full form is that revised universal soil loss equation. Okay, it's called the reversed universal soil loss equation. Yeah.
Mr. Rahman, and all this is recorded, right? I can
yeah,
see
recorded.
later.
And I
for
also send you
today's-
the all of those slide. You can also get the slide, also get the recorded, and also get the practice.
yeah,
no
please.
problem for that. Yeah.
Yeah, please. Okay.
So now it's the RUSLE model. It's the revised universal soil loss equation is widely used for estimating the rate of soil by water.
Okay.
Okay. So mainly it's working for the by
By
water.
floods, you mean to say by floods?
Yeah, flood or rainfall or precipitation.
Okay.
But sometimes soil is also erosion by wind. In this time, RUSLE model is not. It's just consider about the only for the water.
Okay.
Okay, and this is the equation. It's showing the annual soil loss per acre, and R4 is the rainfall erosivity.
Per acre, okay.
I also talk about the later how it will be calculated. L is the slope length. C is the vegetation cover.
Okay.
K is the soil erodibility. S is the soil stiffness, and P is the erosion control practice. Okay.
Achha.
So now here I can get all of those factor, and when I generate all of those factor, and then I can easily apply the formula. I can easily calculate it, the soil loss. Okay, so let's go. So here you can see about that for the RF and runoff erosivity factor. So mainly it varies with the amount of runoff, and the individual is from the patterns. Mainly runoff. Runoff is it can be surface runoff. Okay, so when the water will be moving from one place to another place. Okay, and K is the soil erodibility factor. So mainly this value contained from the 0.1 to 0.45, and low value mainly the sand and clay, okay, content, and high is the slate and the spring. So they are mainly we can get the winter for the low, and we can get the spring is the high soil erodibility for the wind. Summer season or spring season about that. And LS is the topographic factor. Okay, LS is the topographic factor. It mainly adjusts the erosion rates for the greater erosion on the longer steeper slope and less erosion on the shorter flatter slope. and slope length measured from the LS factor. Okay, we can click it. And C is the cover management factor. It is the cover management factor, and it's mainly value from the 0 to 1.5. 0 is the well protected soil, and 1.5 is the soil highly susceptibility to real erosion. So now, how to apply? How we can easily apply the RUSLE model? Just in this time, I need a data source. Okay, so rainfall monthly or an yearly average data I need for that, monthly and yearly average data. So mainly this rainfall data, it generates the RUSLE R factor. Okay, so I can get the R factor from the rainfall data. Okay, soil classification. In this time, we are using at the different types of soil data. Suppose soil texture data or soil classification data we can easily use. Mainly soil classification data, it's called the K factor. Okay.
And from the rainfall, soil classification.
And then digital elevation model. From that we can generate the LS factor. And vegetation cover and management map, we can get the C factor and P factor. When I got all of those factors, I can simply multiply. Then I can easily get the RUSLE soil erosion. So now it's a lot of application to assist soil conservation, confidence state in a farm planning, developing and implementing public policy related to the soil conversion, yield and productivity of soil, better farm management. So there's a lot of application, and it also some limitation. So it's required the users to be aware of the producer limitation, estimation only the erosion, real and sheet, but no deposition. Okay, it's not talking about any types of deposition, and doesn't include the ephemeral gully erosion. Okay, gully erosion in this time it doesn't include in the RUSLE model. Okay, so gully erosion is another type of erosion. It's not talk about the gully erosion, and does not provide the info on sediment characteristics, and does not present the fundamental hydrological and erosion process. It not doesn't present about in the RUSLE model. So this is some limitation. Okay, so now in this time, we just use this algorithm about the conceptual framework of the soil loss analysis by RUSLE model. So it's the follow chart about that soil data, rainfall data, dam data, land use data, and from the dam we can calculate the slope and flow accumulation, and from that we can easily calculate the LS factor. Okay, and land use map, study area. From that we can get the P factor and C factor. And rainfall data provided with the R factor, and soil data provided with the K factor. And when I can get all of those things, then I can easily calculate the area of soil loss using this formula.
Per hectare.
So in this time here is some description about what is the rainfall erosivity or R factor versus soil loss. The estimation of the soil loss was affected by rainfall. Okay, suppose higher the rainfall, high rainfall, we can get the high erosion. Okay. And rate of runoff, which also influenced by the rainfall erosivity. Suppose where the rainfall is high, for this region, runoff is also high. Okay? And the map of the R factor for the study area was prepared by using the following step, GIS environment. So in this time, for the rainfall, here I use a sharp spanted data set. Okay? Suppose if you have the station-wise data, suppose you have the station-wise data, then you can also use it. There is no problem. In this time, I use the sharp spanted data set. Okay, so mainly it's the chart is the climate hazard group infrared precipitation with station data. So basically, it's the satellite data. We are usually use the data, and we can easily get about the precipitation or rainfall data. Okay, and mainly rainfall data is
anywhere in the
globally. We can get the data set as a globally. Okay, but if you want, you can also use here the station-wise data. Then you have to just need to make your suppose there are total 5 stations for your region. You can simply collect the rainfall data for your 5 stations, and then in ArcMap software just apply the IDWI technique. Okay, inverse interpolation. Then make the rainfall map. Then use this rainfall map for your RUSLE model. Okay, it's very easy. And in this time we are using the chart spanted data. And after that, K factor. K factor is the soil erodibility, and the factor used to quantify soil resistivity and to retransport by the shared trace states on ground flow and raindrops. Okay. how much soil will be transported. And based on the recommendation of the different scholars, they are applying this different. You can also get the different types of thought for the different types of paper. I also send you some paper about that. Also, in the slope, length, and steepness, it's called the LS factor. Okay. So in this time, the LS factor of the study area has been generated from the DEM data. Okay, DEM data provide you the slope. And using the flowing step in Google Earth Engine platform, using the NASA SRTM data, we can easily get the slope. So filling up the sync of the DEM of the study area, generation of the S factor using the fill in the DEM, okay, and generation of the flow direction using the DEM. Okay, we can easily from the DEM we can easily get the flow direction, which flow the water will flow, and computing the flow accumulation raster using the flow in direction as a raster. Okay, and calculating the LS factor using the flow accumulation slope raster as an input. And in this time, imported data set. In this time, here I use this type of data in my Google Earth Engine platform. For rainfall, use here the start spent data. For soil data, I use here the open land map soil texture class. Okay. For DEM data, I use here the NASA SRTM digital elevation 30 meter. And for NDVI, I use here the Sentinel. If you want to use here the Landsat, there is no problem. And land use land cover, I use here the Landsat Sentinel models. Anyone can use, there is no problem. Okay, so let's go about that. So in this time, I simply imported all of those data in my code editor.
Seeing your, now I saw it.
Yeah. Okay. So let's go. So in this time, I can simply import it all of those data one by one. So I just so first data is that charts data. So if you want, you can simply click on here and go to the browse data catalog. Here you can get all of those data set. Simply search on the Google. Suppose I can simply search here. So here I can get the daily. Mainly it's provide the daily rainfall data or precipitation data. And it's the painted. It's showing the data is the 5 days average. Okay.
Mr. Raman, if you don't mind, shall I send you the?
Okay, so your study area. Okay, send you.
Oh yeah, 1 second, 1 minute.